children and young adults with cerebral palsy, brain injury, or brain abnormality. The technique develops the pattern of recovery by addressing deep core weaknesses within the circulation of the respiratory system that affects structure, metabolism, and motor and cognitive function. The creator of the Scotson therapy, Linda Scotson, is here with us today. It's quite an honor to have you. Hello. Welcome to our show. Tell us where it all started.
As a psychologist, I became concerned about the contradiction between the huge amount of evidence that tells us that the brain has a remarkable restorative potential, that there are many cells in the brain which are simply sleeping. They aren't used throughout our whole lives, that we continue to develop new neurons throughout our whole lives, that people who have brain injuries that are very slow in onset, like Parkinson's, up to 90% of their brains can be damaged in the affective area before the symptoms show. So why was it that brain-injured children seem to be getting such a raw deal? And I began to find the answer was that there was another system which is critically affected after a brain injury, and that was the respiratory system. And what had happened was the focus had been exclusively on the brain, not on a system that the brain was dependent upon.
Because we would think that breathing is dependent on the message from the brain to breathe, and that's what we are taught in psychology, like you say. Are you saying respiration is independent of the brain function?
If you go back to normal development, what in fact happens is the pressures from the main respiratory muscle that a baby uses, which is called the diaphragm, which fits underneath the rib cage, these gentle pressures affect the tiny blood vessels in the tissues of the trunk of the body between the bones. And what they produce is a little pulse which helps the blood to become deeper and deeper embedded into the blood vessels to strengthen the tissues. And it does something else. There's the actual movement of the red blood cells that creates an electrical activity in the tissue. And before the brain can send an outgoing signal, it needs to have that electrical presence in the tissue. I mean, everybody knows if they lie on their arm in bed and wake up in the morning, they can't move it. They can't feel it. And if they've been lying on it for a long time, it doesn't even seem like their arm. It's off the brain's computer.
Yeah. If your brain is damaged, if you have brain injury, a certain part of the brain or is injured, or there's an abnormality, how do you use, therefore, respiration to heal that part? Can you?
In the first instance, you have to understand that the respiratory system is weakened after a brain injury because it's had to work very, very hard to bring oxygen to the brain in crisis. And at the same time, blood supply from the respiratory muscles has been directed to the brain. So the respiratory muscles have lost blood supply, and they also have to work very hard. And that can happen even if the brain injury occurs before birth. So that these weakened muscles are now unable to create the internal pressures in the body to give the brain the information about where the tissue is and to nourish it. And as the brain of a developing child responds to the earliest tiny movements that the infant makes, the infant's respiratory system begins to be entrained to move with the movement, to support the movement, so that the brain is beginning to learn how to move and how to breathe. And it's gradually taking on board more and more control of those muscle tissues. So it's a gradual exponential process. And the baby begins to develop its respiratory system, if it's a normal, healthy child, by lying on its tummy, breathing against weight bearing. But with a brain-injured child, the respiratory system is so weakened that the baby doesn't feel comfortable in this way. The other thing is the baby has a lot of descending motor problems, usually, so that it can't make tiny bouts of rhythmical movement and therefore encourage its respiratory system to support those movements. In fact, apart from very basic breathing, we learn how to breathe as we learn how to move, and it's all memorized.
Is there a link between someone in a coma who continues to breathe or someone who is brain dead and continues to live, and what you have researched and come up with?
there's the law of supply and demand, that the metabolic demands, that is, the demands of active tissue for oxygen, are limited by the provider, the respiratory system. If the respiratory system is weak, then the possibility of the brain to recapitulate normal development, to respond to active information going in, is limited because blood supply has been reduced and reduced and reduced in the tissues. And interestingly enough, that the diaphragm muscle and the muscles above and below it form a pump which pulls the deoxygenated blood from the veins back to the heart. The veins are a blood bag for us. When we're athletic, more blood is released from the veins into the general circulation. This means that tiny blood vessels in the tissues, the capillaries, do not have sufficient blood supply to them to grow and develop normally either. So the brain has reduced electrical information, and it also has reduced nutrition. As you begin to change it around, which we do by using very light, gentle pressures on respiratory muscle tissues to help to encourage blood supply and to copy the tiny pulses that are created by the respiratory system, which devolve throughout the whole body, then the diaphragm muscle begins to move more strongly, the internal pressures in the body increase, so that the shoulder girdle opens up, the pelvic girdle opens up, the trachea and the muscles of the of speech and articulation become stronger, and the availability of blood supply to the whole system improves, and the brain responds to this.
In conclusion, what is the success rate of your technique?
Well, it's 100%. That's what's so interesting. The theoretical basis relies on the fact that respiration underpins it, and if you change the respiratory system, you will change the development of a brain-injured child.
The Scotson technique by Linda Scotson. Thank you so much for joining us.